Hey everybody, I'm back. This is part 2 of the design of a train logistics system series. Today I'll be going over some of the developments. I've been working pretty hard on the system, trying to integrate the final state machine with the redstone uh, system, right? I wanted to set up a way that I can map the state that the computer is in, or the program, to redstone outputs and have incoming redstone signals trigger transitions in the finite state machine. So, let's quickly go over what I've changed. As far as the hardware block side, not much has changed. There is a design flaw right now that means that this system actually just doesn't work. These redstone links, you know what? You can be included in this. Let me replace these because right now, if you send the high redstone signal to a portable storage interface, it prevents it from making a connection when the train comes in. So that means these redstone links, which are meant to disable the funnels, actually were turning off output entirely. Sorry, well, that would be input and output. Yeah, like they were disabling the portable storage interfaces. So if you want to recreate the system, then make sure your links are only affecting the funnels and not the portable storage interfaces. And actually, in that note, you should also be careful about how you position basically all your links, because, well, I had a situation where I had a link here on the stockpile switch that was being turned on by this link. So, it would just never actually pick up the signal from the stockpile switch. It would be on permanently because of this link. Well, technically this turns off when it's time to output, but yeah, like it was messing up the channel. So yeah, let me quickly set this up. These set to crankcasing. By the way, if you decide to implement the system yourself, doesn't matter what. I actually didn't notice if they connected, but it doesn't matter what items you choose for the redstone link. I do have to wonder, and hopefully somebody lets me know if this exists. Is there a way that you can have the computers modify the signal that's being sent in a link channel directly? I don't know, maybe there's like a turtle add-on or something. This is Fabric. Maybe in Forge there's something that lets you, like send wireless signals, because that would save quite a bit of complexity, right? Because as you can see from last time, I added a couple things. I added a monitor, we had the monitor here. I moved it over here because it looks nicer. And I added a red router block. So the reason I did this is that we didn't have enough sides on the computer to handle all of the output that we needed to handle. So we had, I think, right now there's 7 channels that it needs to talk with, and the computer is a block, so it only has 6 sides, and one of them has to be for the modem, for the monitor, which I guess is not mandatory, but it is nice to have. So yeah, I had to extend the number of sides by putting in a red router block, and I had to develop a software layer for abstracting over like all the different sides of the hardware and basically turn them into logical channels that I can do operation with. So yeah, basically I need to have a file in the computer. I dare not interrupt it right now because I haven't gotten it to work correctly, like turning the computer off and on and stuff to recover its state quite right. But you're just gonna have to trust me and maybe look at the GitHub if you want to recreate it. You have what, screw it. You have the channel map.lua. This file basically just returns a table that has a mapping from the names of the channels to an address, right? And this address is made up of the context and then the side, right? And context is either a peripheral, which should be a red router block, or it could be self, right? So this system here basically lets me map logical things like, you know, output of recoup or the train arrival input, something like that. Lets me map it to an actual I/O side, right? And yeah, I mean, it's pretty neat. It works nice. You just have to configure that, like when you know, if you build a system or if you build more factories. I'm gonna build more factories. Actually, next video, I'll probably have another factory to showcase this on. But yeah, like every time you build a new factory and you deploy the system, you have to change the channel map.lua and configure it to have the correct channels, right? Like it's, you know, that's basically it. Like that's the only thing you actually have to configure every time. But yeah, speaking of the next video, there's two things I want to have. So the system, at least the hardware side, I actually have a better design that I'd like to implement that doesn't have to output, or sorry, like it doesn't have to void any of the items that go in the conveyor lines, right? Because right now, whenever the train, wait, hold on, these things are not hooking up. I'll have to look into that. I wonder why that's happening. Maybe little signal set them right, set them straight. Okay, I'll have to check. Maybe something weird going on with this. But okay, that's beside the point. Yeah, so I have to make sure that no items are left on the lines, right? Like I have to flush out everything. And to do that right now, I'm voiding items, right? Like if an item does not go into the train, it gets voided, which is a huge problem because if the train is not here and yet there's items on the line, which shouldn't happen, but as we just saw, these things don't always connect, which, you know, now I'm worried there's a bug. But yeah, like if these things don't connect for some reason, or there isn't a train here, or the train is full, items are gonna flow through and they get voided, right? So I thought of a better way to do that. Instead of voiding it, we would take it into an additional buffer called a backflow buffer, which is probably a terrible name and there's something better, but you know, two hard things in programming, cation validation and naming things. So yeah, I mean, backflow buffer is what I'm gonna call it. So yeah, like the idea of the backflow buffer is imagine you had another buffer over here where instead of voiding items, you would like bring them over to that buffer. And whenever you're in the output state, things would go into the line. Don't go into the train, they would go to the output buffer, or sorry, the backflow buffer. And then the backflow buffer feeds directly into the output buffer. And the line that goes from the output buffer, sorry, from the backflow buffer to the output buffer, gives priority to the backflow buffer, but it also receives from the factory. So the idea is, as long as there are items in the backflow buffer, those items will be transferred to the output buffer. No more items from the factory will be received into the loop, which means we will never fill up the loop to beyond what the output buffer is gonna be able to hold, right? Which is, well, it's nice. It means we don't have to void anything. But you would need to have like a separate output buffer for each type of item that you that your factory is producing, um, because because of the same problem, right? Where you can't have a line saturate and then want to send more items through it. Because the whole point here is that we would actually be saturating the line. So, yeah, I mean, like you can have a lineup of backflow buffers, and then brass funnels feeding into them with a single line, right? But then you need to have a separate buffer for each type of item. So yeah, hopefully that makes sense. I don't know, maybe it's a little bit five head, but you know, I'm not quite there yet. You could implement a hybrid system where you have a backflow buffer and a void, which you could use like, you know, in case the software messes up or something. So yeah, things still get voided. And otherwise they try to go to the backflow buffer, which then goes to the output buffers, and everything is good in the world. Or so I hope. Anyway, yeah, that's for the next video. Hopefully I can implement that. I'll make another factory. But yeah, for now, this is what I got. Again, GitHub in the description. Anyone wants to check out the system, implement it themselves, this is Create Astral. You need to have the CCC bridge mod if you want to implement the system, because you know, we got way too many channels. Oh, one more thing. These input channels, you know, they're input because they have like the little halo around the, well, it's not a halo, it's like a, I don't know, input icon. I mean, that's what it is to me, but it's just a white circle. Yeah, so they have that white circle, which means that they're input. Yeah, so these input channels have to be on the computer itself. It can't be on the red router block. And that's because, at least in Create Astral, I don't know if maybe there's a better, like, you know, updated version of CCC Bridge that fixed this bug, but the red router blocks do not generate redstone events whenever they receive a signal, which they're supposed to. So that means that, well, the way I designed the program, it expects events, right? Like, there's no, you could make this work without events, but it would be laggier because you'd have to poll, like you'd have to, every single interval of time, you have to check if anything changed, which is very inefficient. So it's usually, you know, it's just a lot better to do it this way. Even though I guess it is a bit ugly having all the links over here, but I mean, look at my world, dog. Right? I'm not trying to make this too pretty. But yeah, that's, you know, just one small caveat. Your outputs can be on red router blocks, and you can have as many red router blocks as you want. You just have to make sure that you know their names. So this one is like red router block 11 or 10 or something. You know, just write it down. It helps to, as you place them down and everything, write down which one is which. Then you place the outputs around this. You should only put outputs here. And if you're going to use multiple, make sure that you don't place them one next to each other, because if you had another redstone link here, this might activate this. Actually, I think that's only true if these are input, and you should not have inputs connected to the red router block, so maybe that's not true. But anyway, yeah. I had to change the state machine. Had to add some more states for handling, you know, redstone IO. One of the main eureka moments, revelations, epiphanies, etc. that I had was to use a leave state instead of an active to tell the train to get out. Because what I was thinking of doing before was to make it so that when it transitions into the inactive state, it tells the train to get out. But the problem with that is that if you load into the inactive state because you unloaded the computer, you unload the chunks, but a train came into the station while everything was unloaded, you're gonna have a problem, because you're gonna tell the train to get out because you load into inactive without handling the train. So you're basically skipping that train, which is not good, right? Like, we wouldn't prefer not to do that if possible. So it's much better. It's very, you know, it's preferable to instead have a system where the leave signal just gets flashed for a little bit of time, and then we go into inactive, and if we load back into inactive, nothing happens, right? So, that's big chillin'. Next thing that I need to implement here is it's unrelated. Well, it's kind of related to the state machine. When I load into the program, right now, it looks into the redstone state as it loads, but it doesn't know if anything changed since the last time it was loaded, right? So why does that matter? Imagine this is unloaded, train comes in, then the chunk loads, right? And there was nothing in the station before we unloaded. The train arrival signal used to be off. We load, it turns on because there's a train at the station. Then the computer loads because the computer takes a little bit of time to load, I think. Don't quote me on that. But at the very least, it might happen at the same time, which means it's unreliable. But yeah, computer loads. It checks its state, the redstone state, and it sees that the redstone link on top of it is on. But it doesn't do anything. Because the way this is coded right now is that it doesn't do anything when an input is on. It does something on a rising edge, which basically means when you go from low to high, right? Or it also does one thing on a falling edge, which is when you go from high to low. But basically, if this is on as the computer loads, it won't do anything. It needs to go from off to on, or at least at the software level, it needs to think that it went from off to on, which is pretty easily done if I tell the computer, when it loads, I tell it a lie and I say that all of these things are turned off, right? And then it would check the next time it receives a redstone event, it would check and it would see that they turned on, right? Or I guess I could make it manually check so that there's no waiting time, which actually in this case, nothing would happen forever because there's a train at the station. It's not doing anything. It's in the inactive state. So yeah, I would have to manually tell it, wake up, right? Check your 6, check your redstone state, and then because I lied to it and told it that everything was off, and it sees that everything is on, it's like, oh, let's generate some events, and then the engine gets going, right? So I'll try to implement that. I don't think it's going to be too complicated, but you know how it is. Everything's easier on paper. But yeah, that's what I've done. If you want to implement the system yourself, if you want to load into your world, there is a GitHub link in the description. I have an export script. I actually broke it. I don't know. It's not working for me. It's just a cute little Python script that's supposed to upload the files to Pastebin, but yeah, it stopped working. I don't know if I got like rate limited or something, because Lord knows I was debugging, so I was loading that thing in and out a bunch of times. So yeah, maybe I got rate limited or something, but it's not working for me right now. Maybe it works for other people. Yeah, so if you want to load it into your computer craft world, you can use the export script. If you export it manually though, make sure startup.lua has a part of it that says pastebin exclude. So you want to make sure you don't copy that into the computer, because that was some stuff I was writing to mock the computer craft environment to emulate it basically, so I didn't have errors pop up when I tried to run it locally. But I ended up scratching that because, well, it's a lot of stuff, and it wasn't really worth it because I ended up making that export script that makes it pretty easy to debug by loading it into here. Anyway, look, all that stuff is relevant. If you want to load it into your game, just go into your computer, pastebin get, and then the code, for your export script, I made it tell you the export script, or sorry, the pastebin code. It gives you the command that you need to import it to your computer, and then make sure that you write the channel map. So each of these things you have to set them up. Make sure that all your input signals are on self. They need to be on the computer itself. They cannot be on red router block because they're bugged. And yeah, then make sure your startup is there. And yeah, then you're good to go. Startup runs whenever the computer gets loaded or whenever you join the game or anything like that, so don't have to worry about that. And yeah, I mean, as of now, you actually do have to you have to hook up a monitor, because I didn't set it up to handle, like, you know, what happens if it doesn't find a monitor. uh Sorry. I mean, they're pretty cheap in this mod pack, so if you're building this factory, hopefully you shouldn't struggle too much to build a monitor and like a modem and a few networking cables. Yeah, so that's the video. Hopefully you found this insightful. If you have any ideas, any interesting observations, if you think the system sucks, if you find the critical flaw or something, let me know. And yeah, that'll be that. Thank you.